All right, welcome back. We're going to talk more about HVAC designs today, and there's a really cool development that I think is so useful and important, which fills a gap that hasn't really been there. I did a video recently about doing your own duct design by hand, and you can imagine, based on just the way that you say that, it sounds disgusting, and it is disgusting. And so you don't have to do that anymore. This is Russ King. Russ, hello.
Hello, glad to
Russ
be
has
here.
been on this channel a bunch of times. We're buddies. He has developed the software Quick Model, which is an option for people who want to be able to do Manual J and S&D. It uses energy gauge, right? You guys are using another engine to do the actual calculations.
Energy Gauge is our ACA approved Manual J load calculation engine. Yes,
hmm And I have to
exactly.
say, hopefully it puts pressure on them. The reports that come out of that are not my favorite. Like, I think that looking sexy while you do this and giving people sexy reports is very important. So please, like, take that into advisement, Energy Gauge. But the thing that's sexy about your software is that it's a 3D modeling environment. Like, you actually build this stuff in a 3D modeling software. And
Yep,
then people can see what the ductwork actually is going to look like. Was that always like a primary goal of yours?
it really was. Way back in the day, I use RightSoft my entire career. I've literally done thousands of designs on RightSoft, and I just didn't like how it looked. I didn't like all the stuff, and um, I don't know if you've heard the story, but my son graduated from UC Santa Cruz with a degree in computer science, and he wanted to design video games, and it took him a little while. That's a very very competitive industry to get into, and so he graduated from college. He lived with us, and he was in my office. And I said, "Hey, Connor, I've got this great idea. Could you help me design a prototype that I want to show some people?" I actually wanted to show this to Rightsoft and to Elite and everybody else and say, "Here, this is what it should look like. It should be 3D." And so he wrote a little demo. I'd explain him what ducts were. He kept calling them tubes, and I go, "Can you make a little 3D house?" He go, "Oh yeah." He banged it out, and then I go, "Can you put these little tubes in the attic?" He goes, "Oh yeah, no problem." And after a couple hours of getting him to do this, I realized, like, dude, this is not a prototype. Let's run with this. And so
Mm.
I basically hijacked his career, his desired career of designing video games, and we started Coded Energy and Quick Model the software. So it's been a lot of fun. It's been wonderful working with my son. He's a good kid.
Awesome. And like anything that's really exciting and like new and innovative in this niche, and I'm sure in other fields as well, you guys are just two guys working on
Mhm.
this. And like
Yep.
so thank you for doing the
Sure.
work that you do. We
Yep.
also are highlighting Amply, which is an on-site, scan with LiDAR kind of a thing. And those tools like this are what is going to make this really go places. And I think from my perspective, yours particularly is so useful because it gets the actual homeowner to understand what it's supposed to look like and then be able to quality control their own job. When the installer comes in and installs the ductwork, it should look exactly like what this 3D model looks like. And
Yep.
so I can just easily be like, well, that's not how that it's supposed to go that way instead. And looking at the RightSoft plan, 2D, and one of the things I'm always explaining to my clients when I'm using RightSoft is like, hey, just FYI, I'm trying to make 3D look good on paper. So you feel free to put the dehumidifier on top of the ERV if you want to, because you get 10 feet of ceiling space. I
Right.
can't do that because it looks crazy on a piece of paper. So I think that there's a lot of strengths to what you're doing. Can you go ahead and open up the software and run us through what it
Yep.
would look like to
Absolutely.
develop this?
Yep. And since you mentioned Aptly, I'll take the opportunity to mention that we just added lidar to Quick Model Eagle, our for
Oh,
full version.
nice.
Yeah,
Great.
you can purchase any or download any lidar app that you can find in the Apple Store and scan the house. And if it has a tool in it that does a floor plan and creates an OBJ file, we can open that directly into. We can open it
Nice.
in Kestrel too, but
That's
uh,
great.
um, yeah, the big
Flexibility and
difference.
options. We just need more options for all this stuff.
Exactly, exactly. You were talking technology has come so far just in the last 2 or 3 years, it seems
Mm.
like that, I remember I was training people to go out to a house with a tape measure and draw a floor plan with a tape measure, and if they were really lucky, they had a little laser tape measure they could shoot across the room. It still took a couple hours to make a decent floor plan of a house. So this is our virtual world. You can see there's a sky and everything, and if I look way up, there's even a sun up there. But this big square here is basically imagine this is where you're going to roll out a life-size set of floor plans. The assumption is you've already done your load calcs.
I've got clients who come back to me with cool calcs that they've done themselves that they might
Yep,
need some tweaking on, like, I don't know what I'm doing. I just put a bunch of numbers in here. You could use
exactly.
a Manual J from somebody who does just the calcs, and doing a Manual J is easy. This is really the hard part. I charge more for this duct
Right.
design part because it's just like, and then you're going to go back
Yeah,
and forth about like, oh, can we move this here? So I'm very
exactly.
excited about this.
Exactly. Yeah. So literally any software, all you need is room by room loads and airflow at a certain static pressure. That's the only three things you really, really need to do this correctly. After that, you're just going to build a 3D mock-up of the house. And the only reason that would need to be accurate is because one of the things we produce is a parts list for ducts. And so, if you built your 3D model of a house that was twice as big as it needed to be, it would show your ducts being twice as long as they needed to be. Your areas have already been taken care of in your load calculations, all the things that require accuracy on the geometry of the house, that's all for the load calculations, and that's presumably all done. All right. So this is really just the 3D portion of it is really just to for spatial awareness, I guess, of the duct system and things like that. I'm just going to place a horizontal unit.
By the way, can you do rigid duct in Kestrel?
Absolutely. Yep.
Great.
But just like installing flex duct is easier, drawing flex duct is a lot easier too than
Mhm.
drawing rigid, because you just have to, if you move this register over, what else do you want to move with that register? You want the duct that it's connected to, but how about the trunk that it's connected to? And things can get complicated pretty quickly if you try to modify an existing drawing. But it builds pretty simply. It builds pretty easily. Um, and so then the next thing is to just put some registers. So you just click on registers, and I'll just put some ceiling registers in here. Tab rotates them.
The system we're looking at there is a furnace plus an air conditioning coil with a supply plenum return plenum on each end, right?
Yeah, and it can also be a fan coil unit. It's just saying that this blue one is the coil and the red box is the fan box. And it could be a fan coil where they're combined. The general nomenclature in HVAC plans is that the X represents supply, and the single diagonal line represents return. We've got upflow, downflow, ducted mini split, ductless mini split, and package units you can
Wow.
place.
So at this point, Russ, is it important? We've already done the manual S as far as my practice goes before we start talking about ductwork, is like figure out what kind of equipment we're talking about here.
Right.
So we've already done the manual S. Have I put that information into the software
Not
anywhere
yet.
yet?
Nope. Yeah,
Okay.
not yet. Not yet. We'll do that in just a second. Yeah. So let's say the assumption is in this house, we've decided on a 2-ton. Okay. And you've picked your equipment. So you found your fan table for your 2-ton fan coil unit, and it says it'll put out 800 CFM at zero point 0.4 inches of static pressure. That's the only numbers you need to know is 800 CFM at zero point 0.4 inches of static pressure. As far as manual S goes. Okay. I'm just going to go ahead and draw the duct system.
So these plenums, can I resize the plenums to make them longer or to make them bigger?
Yeah, absolutely. Great question. So when you click on something, down here, you can see all the different, you can change, like right now, this is 36 by 24 by 24. In this particular configuration, they all have to be the same 24 by 24 this way, but you can change the lengths on them.
Mhm.
But whatever you set for the height and the width, they have to all be the same. Just
So if I wanted to be a freak and put my favorite 31-inch by 28-inch filter on the side of this thing, can I do weird transitions, or is that something that's like a little bit that'll be a later?
No, you absolutely can't. You
Okay.
can put you would put a rectangular sheet metal extension or transition piece on the end of it, and then put whatever size box you want it to extend into. Yeah.
Nice. Great.
Yeah. Because this is so realistic looking, people get a little hung up in the realism of it. And let me just say this, it doesn't have to look exactly like what it's going to be in order to accomplish what you're trying to do. You could draw whatever size filter you wanted to draw, but just tell the software it has this much of a static pressure drop, and it doesn't matter how you draw it, it just knows that it has a certain static pressure drop. But you want it to, people are like, oh, I want it to look exactly like what it's going to be. And certainly the realism is very, very useful and very helpful, but it tends to make people think they have to be very realistic in their drawing, and they don't. They really don't. Okay, it's one of my favorite parts. The flex ducts, you literally just check the where you want it to start, and then you click on the other end and it draws this little line saying, okay, I'm going to connect these two together, and you hit enter and it puts a flex duct there.
Beautiful.
These little orange handles here, um, when it's highlighted like this and you hit the enter key, it's going to turn into a fitting. And the fitting that it's going to turn into is whatever it says over here in this drop down, and it defaults to TY. Okay. So it's going to, so it's highlighted and I click enter and it turns into a TY. Okay. And if I zoom in on it, you can kind of see it's and then the tab will rotate it. And then I just highlight that. I highlight that. I hit enter and it draws it up. Well,
Beautiful. Well, you're making
all
this
right.
look super easy. By the way,
Yeah,
I just want to make a point because, like Russ said, flex duct, most of the reason I don't like flex duct very much is because it doesn't, we spend so much time talking about 100-year houses on our channel, on the build show, all this stuff. And then we install a 30-year duct system in a 100-year
right.
house. And it's like, you're going to be replacing that in 30 years, So when you're burying it inside of drywall, that's something we just like to like point out. But you did an experiment recently where you like coiled up. Everybody's like, "Oh, you got to install this stuff super straight," and you actually
Yep.
like had an air handler, and then you just like did a whole 360 on the ducts,
Several
and
360s. Yeah, actually. Yeah. Yeah.
and you had like hardly any actual drop.
15% reduction
Yeah.
in airflow. Yeah. So,
Okay.
one of the big complaints against flex duct is its performance. And it's the same performance as one size smaller sheet metal. So in terms of airflow, and it's very forgiving. It's very forgiving. When you make an elbow with a sheet metal, you make a hard elbow. But when you make an elbow with flex, you can really have a gradual elbow with virtually no pressure drop whatsoever. But the one thing I will grant you that sheet metal is superior on is rodents. So who knows? It's certainly not 100 years, but I've seen sheet metal rust out in 20 years. So I
Hmm.
think it just depends on your climate
Everything
and
is a
stuff
tool.
like
You got to
that.
use it the right way. Yep.
Exactly, exactly. So my duct design philosophy is, to me, air likes to be symmetrical. If air's coming down a box, it likes to have an equal choice of whether to go left or whether to go right. And in terms of predictability, if you could split your air perfectly equally, you would be able to predict that, as opposed to saying I want a 60-40 split. How could you make it 60-40? How exactly could you make it 60-40 or 70-30? But if it's 50-50, that's easy. You just make it the same on both directions, and you know that the air is most likely to go half this way and half that way. So it gets it into predictability and self-balancing and all this other stuff. So I
Yeah.
try to put the same number of start collars on one side of the plenum as I have on the other, and have roughly the same amount of air going one direction. But of course, the architecture of the house will always override what you think is best.
And for
Um,
those of you who are going to be using Kestrel to design your own ductwork, just know like this is a lot of creativity goes into this. Like it's
yeah,
hard to do because you have to make decisions and you're actually like making something instead of just doing math, which is what a load is. So
yep,
this is, there's no right or wrong answers necessarily. Like we just talked about, Russ, showed that you could actually like do the ducts really, really badly and still get like not a terrible result. So, if you're doing your design, follow just basic kind of principles. Don't have stuff come out of the top and the bottom if you can, because then you're playing with buoyancy of like
yep,
cold air, hot air. But out of the sides, equal. T's are good, things like
yeah. They say never put a start color on the end here. I will admit I have put start colors on the end, but that was because I knew that air had a lot farther to go than
that.
the air coming out the side, and I knew it was going to get preferential treatment because the air is crashing into the end of the plenum, and so the static pressure right at the opening there is going to be greater, and I was okay with that in that particular situation. But if you want, like I said, predictability, it's the ability to predict the air, and what we're doing is we're sizing ducts to a certain size in order to get a certain amount of air to a room. And if you want that to be predictable, you have to follow certain rules of thumb and certain guidelines and things like that. And a lot of the guidelines are not written anywhere, like the whole thing I just mentioned about being symmetrical and stuff like that. But and I tell people there's literally 1,000 ways to lay out a duct system on a house that will accomplish basically the same thing. And different contractors have different preferences. You'll see this house, for example, there'll be no TYs. Every single register will come straight from the plenum, right?
Mhm.
We call those home runs, or some people call them octopus or something like that. But just every duct comes straight out of the plenum and goes right to the register. Um, it's just, costs and things like that.
Now, Russ, we're at a really dangerous point where somebody's going to stop watching in about 5 seconds, and they'll be like, "Okay, I get it. You just build this plenum, and then you just connect all 6-inch ducts to it," which is what it looks like we're doing here. This
Yep.
is not what this software is actually like. You're going to put in the numbers that are going to then tell it, "Oh, this duct needs to be 4 inches. This duct needs to be 8. This one needs to be 6. This one needs to be 10, etc." Right?
Exactly. Yeah, excellent point. And so it's drawing the ducts based on a default number that is set right here, default duct width of 8. So as I place a duct, it's putting down an 8-inch duct. I can manually change those. Like, let's make this one a 16. Okay, and I've got the colors turned on, so the red is return and the blue is supply. Um, and you can move stuff around. These green handles just kind of change the angle of attack where it's coming out of, where it's attached to, so I can put it in like that. And this might be where you'd want to draw a roof to say, do I have room to make these nice gradual curves? Now we have to size it. Okay, so what the software needs to know is, all right, you want to move a certain amount of air. How much air do you want to move? So you go into the data tab, and there's a table in here called the air handler table. It calls it 1.1. You could name that. How much heating airflow do you want to move, and how much cooling airflow do you want to move? This comes from the airflow tables for that particular fan coil unit. And I'll just use some generic numbers. I'll just say 800. Heat pumps typically run on the same speed in heating and cooling mode.
And
And then it
FYI,
was
everybody, if your manual J was like, oh, it's this many BTUs is your load, I'm going to imagine something that's running 1100 CFM. It's not a target you have to hit. That's just something that the software made up to deliver those BTU. Isn't that right, Russ?
some software, yes, not ours.
Okay, good.
Yeah. It will estimate what it thinks the software, and that's actually based on a really, really old school way of sizing ducts on that there's a certain amount of BTUs in every cubic foot of air. But the kind of the newer way to do it is you have a load of your house, you know what that load is, pick a piece of equipment that's going to meet that load and not be too big and not be too small. However much air it takes to meet that load, design your ducts for that much air. And what we're finding and what's happening is houses are getting really efficient. So these giant houses have these little tiny systems in it, and now the question is there enough air to even move the air around in the house? How long is it going to take for when a CFM of air comes out of the far room? How long is it going to take for it to get back to the air handler? And that's actually covered in a new manual called LLH, ACA Manual LLH, which stands for low load homes. And it talks exactly about if your system is so small compared to the size and volume of the house, is it going to mix well? Okay, so again, this is the only two manual S numbers you need to know. Well, three technically, is your airflows and your static pressure. Then I'm going to go into the rooms table. So here is some heating load numbers, and here are some cooling load numbers. So that's what we need to type in there now. Let's just say, hypothetically, all you had was a block load number.
Hmm.
Okay, you did not have room by room. You could make up room by room airflows. And what you would not want to do is do it based on square footage of the room, right? You absolutely could. You could say, okay,
That's,
um,
I think, what normal guys are doing who are not thinking about
exactly.
this is they step into a big room and they go, oh, I need a lot of air.
Exactly. So there needs to be a way, and I actually came up with something a long time ago, and I'm very hesitant to share it, but it was like a little point system to say, okay, look at this room. How many square feet is it? Write that in. How many square feet of west facing glass does it have? Write that in. How many square feet of south facing glass? Write that in. How many square feet of roof exposed to the attic does it have? How many square feet of wall does it have? And you write those in, and it has a little point system. For this, add 2 points. For this, subtract 1 point. For this, add 2 points. It will prioritize rooms that have west facing glass. Okay.
Yeah.
Which is exactly what Manual J does, right? It's just, you've already
Kind of,
picked your.
kind of. I'll give you a kind of on that. And this, by the way, is a really interesting difference between Russ's way of thinking and my way of thinking. Russ worked in production homes for decades. and has designed more homes than I will ever design for HVAC. And you actually like then knew how those homes worked. And Russ found out that like they work pretty well with just making a certain assumption. So Russ is a much more reasonable extremist, more reasonable than me, and I am more reasonable than a lot of other people within this field that don't sweat the small stuff.
Exactly, exactly. And honestly, that comes from I ran 2 mechanical engineering departments, and I was blessed that almost every single design we did, we had field people who would go out and test those houses. I would try to go out, and when I could, like if I were doing the first houses in a subdivision, I would go out with them and test them. But to get that feedback, to draw a set of plans and say, I want 98 CFM of air to come out of this register, and then they build that house 20 times, and every time they test it, that 98 is the design target, and the measured is 112, or 115. It's like really close, but a little bit better than what we designed to. When you get that feedback after year after year after year after year,
And that's the
but
scary thing about high performance homes, by the way. If you're watching this channel, I bet you're going to be using Kestrel to build a high performance ductwork. And it's really scary the first time. Once you've built a house that does all this stuff and you're like, oh, yeah, it totally works. Don't worry about it. Then it'll be a lot less scary. But like it's supposed to be intimidating when you're
yes,
diving.
I make a huge point of that whenever I teach classes is you cannot design in a vacuum. You cannot do designs and then hand those to somebody and never hear about it again because you don't have that feedback. You have no confidence in your own designs. And after you build up confidence, and all of a sudden you get a homeowner calls you and says, "Hey, my house isn't working. You designed it. What's going on?" I used to love those. I was like,
Yeah.
yes, because I
Yeah.
know it wasn't my design. I mean, what are we going to find today? Because I know it's not my design. I know exactly. I'm going to go out there and I'm going to find exactly what's wrong with this house, and it ain't going to be my design because I know. So, okay, let me. Here is an example of a room by room load calc. All I need is these heating load numbers right here and these cooling load numbers right here. That's all I need. What you want to do is check to make sure that these totals match your totals from your other software. And if they don't, it's no big deal. It's close enough for this purpose. So the point is that you're putting in a load for heating and cooling, okay? And what it does is it says, okay, this room has a heating load of 166 out of a total of 16,661. What percent is that? So it takes that number, divides by that number, and that puts it right here. So it's 0.01. So it's 1% of the total load. So if it's 1% of the heating load, it needs 1% of the airflow. So it takes that number and it multiplies times the total heating airflow, which turns out to be 8 CFM. Then it does the exact same thing for cooling.
And then what you're actually doing here is the software is going to pick the bigger of those two numbers per room, right?
Exactly. Yeah. That's this last column right here, this very last column.
And you can see that in that last column that those numbers do not add up to 800. They add up
Right.
to 924 instead. So don't worry too much about adding up these rooms and being
Exactly.
like, oh, why does this not, I need to get a bigger system now because this target CFM, I'm not actually hitting it. That's not what this is doing.
And I call that one of two big safety margins in Manual D. So the fact you're designing your entire system to handle more air than it needs to in either heating mode or cooling mode, that's one safety margin, okay? And you can always damper down. It's very easy to damper down airflow. It's very hard to damper up airflow. And then the other safety margin in Manual D is that if the airflow you need isn't enough for one size duct, it goes up to the next size duct. And chances are that duct can handle more air than you need, but you had to go to that size because the size smaller didn't work, wasn't enough. So every duct you install is going to have some excess capacity built into it, just by law of averages, right? And so that's why every time I designed a system to be, I was doing furnaces back in the day, it'd be half-inch static pressure we designed to, and I would design to 400 CFM per ton. They would go out and measure it. The static pressure would actually be a little bit better and the airflow would be a little bit higher every single time because of that little roundup that Manual D does. Okay, so now we've got our design CFMs right here. So now we're going to size a duct to this room that will give us at least 8 CFM. So the next thing to do is to calculate our friction rate. This over here should look fairly familiar if you've ever looked at a Manual D friction rate worksheet. You're not supposed to go above 0.18. You're not supposed to go below 0.06. here's the 0.4 static pressure we put in, and here's the 800 CFM that we put in. Now it just wants to know what miscellaneous pressure drops do you have?
That are
Okay.
going to be built into the system.
Exactly. So balancing dampers, a typical number for that is 0.03. Return grills, a typical number is 0.03. And supply outlets or registers, a typical number is 0.03. Now, what that is saying is I'm going to pick a register in manual T. I'm going to pick a register such that it's not going to have a pressure drop more than 0.03.
But
Um,
your software is going to choose auto size grill sizes for us, is it not?
No, not the grills, not the grills, just the ducts. You
Ah,
still
okay.
have to what you're saying here is when I pick my registers, um, I'm gonna use 0.03 to pick my registers.
Can we put in also the filter being like zero point 0.1?
Yes, a lot of people point one in here, and that is a bit of a dream in most cases. So whatever number you put in here, you're
Make sure it's there.
saying I'm going to size my filter so that it's no more than this, or at least not much more than that. Okay. And then there's all these other things. It's really and honestly, it doesn't even matter where you put these numbers, as long as you put them somewhere in this table. This is just a list to kind of remind you of things like, do you have one of these? Oh, do you have one of these? Oh, do you have one of these? And if you don't, just ignore it. Okay.
Right down here, we've used up 0.19 of the total that we have the zero point 0.4. We have
Yep.
0.21 left to build the ducts with. And is this your total end friction rate? That seems really high,
Um,
right? Because we are not
yeah,
supposed
that
to
is for one.
pass
Let's see. So I'm
0.18.
going to go into it needs to calculate all the duct lengths. And I forgot to do this earlier. When you're in the data tab and you go to the rooms, you need to go to the ducts table. It's looked at what you've drawn and it says, okay, this is how many feet of stuff you have. Now I need to go back to the friction rate table and you'll see it has a better number down there. It's 0.11 now.
Very good. Okay, great.
Okay.
So I
So
have to visit that sheet in order for the software to go boink.
so when you draw the ducts, you draw some fittings in there, and fittings have equivalent lengths. And so there's an equivalent length table where you can come in and it takes a best guess based on how you've drawn it. And you can edit this. You can say, well, I didn't draw this extra sharp angle on here. So I'm going to come in here and I'm going to throw in some extra equivalent lengths. So you can totally edit this. And you've got equivalent lengths down here. And then at the bottom, you got your friction rate. Now, the interesting thing is that this is calculating a custom friction rate for each individual run. Back in the day, and it's still, some people still do it this way, is they will pick the worst case run and use that friction rate. That comes from before we had computers.
Yeah. And Russ,
We have
correct me if I'm
computers now.
wrong. Doesn't Manual D do it that way? That's the way RightSoft works it, unless you specifically enable a secret feature that they don't want you to necessarily know about because it's kind of against Manual D. Isn't that right?
It's not against Manual D. That's the old way of Manual D. That's the way Manual D used to do it, and it still does. But Manual D also says that you can use a custom friction rate for each one, but that it's a lot more work. Well, with software, it is no more work at all.
Right.
It's zero work.
You got to press the
So
button though.
yeah, I encourage people to use custom friction rates when they can. It, if the difference between your best run and your worst run is not that big, it doesn't make any difference. But if you have a really short direct run and a really long run that goes to a bunch of fittings, and they both need 100 CFM, you want those to be two different size ducts. You don't want them to be the same size duct. And if you use one friction rate, they'll be the same size duct, and that's not correct. All right. So it just kind of depends on the house too.
And in that case, you'll end up using those dampers that you're building in on every run out a lot
Yeah,
more because you'll need to.
you'll be damping down all the short runs, which you don't you shouldn't have to do on every project. Yeah, let the duct sizes do that for you. Put in a smaller duct size and you won't have to put a damper on there. Now, there is a statement in there that says there's no such thing as a self-balancing system. I would argue that that you can get close enough with just by sizing ducts. If you're using odd size ducts, there's a lot of people who don't use odd size ducts. They can't even buy 5, 7s, and 9s at their local distributor. They have to custom order 5-inch, 7-inch, and 9-inch ducts. And that's how you know they don't do manual D in that part of the world,
That's
is they're
right.
not
Well,
using odd
man,
size
I
ducts.
mean, I hear from people all over the place that don't have access to that. And by the way, just so that people are listening, know The problem is not placing the custom order in the first place. The problem is that you're going to run out and you're going to need to run to the store real quick and grab something. And you can't do that if it's a custom order. You're going to wait another 2 weeks.
Exactly. Exactly. So this is calculating this particular friction rate is 0.111. All right. And that is for this run right here. If I click this drop down, it'll show all the individual runs and I can see what it is for each individual run. Or
Beautiful.
I can click up here on and open up the total equivalent lengths table and it will show it right here. And these are
Nice.
all pretty close. You've heard people, rant about rules of thumb and using a 0.1 friction rate, stuff like that. I try to get my friction rate to be around 0.1 because 0.1 results in duct sizes that seem reasonable to people.
Hmm.
Manual D allows you to use a friction rate as high as 0.18 and as low as 0.06. Okay. And I will adjust things until most of my friction rates are between 0.08 and 0.12.
Hmm.
So right, just a little above and a little below 0.11. Okay. And if I look here, I've got 0.117, 0.119, 0.111. And this is a really simple layout. So they should all be 0.1, maybe a little bit higher is makes sense to me. Well, how do you adjust? How can you adjust your friction rate? That's a very easy answer. Well, here's the equation right here. You probably can't read it, but it's available static pressure times 100 divided by your total equivalent length. That's a very simple equation. So if you want your friction rate to go up, increase your static pressure or decrease your total equivalent lengths. That's in the numerator or the denominator of the equation. So just let me just show you really quick, just as an example. Let's say I felt that these were a little bit high. Okay, all these friction rates here. Let's say I wanted to make them closer to 0.1. The easiest way to do that is to go back to your air handler and you say, okay, instead of 0.4, what if I ran it at 0.39? And I think it went down a little bit. That was still a little bit high. I could make this one be a lower friction rate by adding some equivalent lengths.
You could also start choosing different fittings at this point, right?
Yes, yeah.
Like they make
Usually,
things that have veins in them. They more expensive,
exactly.
more turning pieces, things like that.
Usually the problem is going to be, especially if you use the trunk and branch style of duct layout where you have this long extended plenum trunk and way out the end you got stuff coming off it. Those typically are going to have the friction rate is going to be too low. It's totally counterintuitive. It's the friction rate is going to be too low, which means you don't have enough static pressure. Okay. And so that's where you start looking at and saying, okay, well, how can I either increase static pressure or reduce fitting lengths, equivalent lengths? And that's where turning vanes and different kinds of takeoffs and stuff like that will come into play. And you try to bring that friction rate back up. I have a whole blog article on my blog, russellking.me, that it's called Friction Rate Explained, maybe. So if you just search for the word maybe, it'll come up. And it talks about, it goes into a lot of detail on friction rate. It's probably one of the most complicated topics in duct design is friction rate. The first thing they screwed up is the name. The name is terrible, friction rate. It really should be called available friction because higher is better. When you say, oh, higher friction rate is better, like that doesn't sound right. You don't want more friction. No, you want more available friction. You want more friction to work with. You want a better friction budget to work with. So, okay. So anyways, then you go to the data tab and we're in the duct table now. So here is each individual run. Each room has one register, so it coincides with the room names. If you put two registers in one room, it splits the airflow in half. We haven't hit the magic button yet. The magic button is down here in the bottom that says auto size ducts. So if you're used to using RightSoft automatically does it. It's like a spreadsheet. When you change a number, everything automatically adjusts. This is a little different. So this you got to get everything ready to go. And then when you're ready, once you have all your airflows and all your friction rates and you have your duct system drawn, then you hit the auto size duct button. Boom, they all change. So now you got 7, 8, 5, 4, 7, 8, 10. Go back to HVAC draw, and down here is a button that says change labels. Click on dimensions, and there's a little slider to make it bigger. And there you go.
Nice. Beautiful. And then the way that you're exporting still at this point is that you just need to kind of spin this thing and take screenshots of what
Yes.
this looks like,
Yeah.
right? But then you've got
Yep.
the map.
Yeah. I've had really good luck. What I do is I'll take a whole bunch of 3D isometric screen snips and I'll plop those into a Word document and send that to the contractor, and they can print that out and hand it to their guys in the field. And they seem to really like that. They seem to appreciate that they're looking at it from different perspectives and stuff like that. We have a cool feature to show homeowners. Is there's a button in here that says spin camera. So if you use your Windows snipping tool, there's actually a video snip on here. So you take a video snip, you tell it what you want to record, and there's a little button up here in the top right that says spin camera. And you just record a little video going 360 degrees around the house, and you post that so they can link to it and look at it. If you go into free draw is just some tools that you can draw stuff that don't affect your design at all. So like if you want to draw your ERV, HRV, you can draw it. It won't design it for you, but if you want to show it in your layout, you can. But we've added this very cool tool here. It says condenser. All right. And then you hit Alt, click, and it places a condenser.
Mm. And
And
you
then
can
it's
run the
got
line
these
set.
and it's got these little handles here, and you can run the line set however you want to.
Nice. And it automatically communicates with the manufacturer and gets the D rating for all of those trims.
That would be nice. That's on our to-do list.
That's cool, man.
But what it will do, there's a button called Show Dimensions. It'll show you the line set length and the rise.
That's slick, man. Okay, so how can people get a hold of Kestrel to be able to use it for their projects, whether they're a professional or a homeowner?
Our website is quickmodel.com. And if you scroll down a little bit, you'll see a 30-day free trial for Kestrel. We encourage people to try it out first. It's $199 for a 1-year license to use it, and it's
Great.
unlimited use.
And that's, but if you're watching this in a future year, just know the prices should and should go up. So
Yes,
just know that.
we
Don't hold Russ to that number that he just said.
exactly. We've been in introductory pricing for 4 years now.
Right. Okay.
Yeah,
Well, we're all rooting for you to actually start making some money. So
hey,
that's
we
important. We don't need you
appreciate
to
that
run.
very much.
We need you to
Yeah.
not burn out and then go away. You got to keep on working for us here. So thank you so much, Russ, for showing us through this. I'm going to look forward to using this with some of my clients. I hope that they will use it. By the way, it does look like a scorpion. If anybody else has noticed that, that's
Yeah.
kind of scary and sexy at the same time.
Yeah.
Russ, thank you very much. Keep up the great work.
My pleasure. Thank you very much.
All right. And thank Connor for us all, please. You
You too.
guys make sure that you comment below if you have uses for this that you think are interesting and maybe off topic. Make sure that you like and subscribe. Tune in next time.